Hello students, I am Vaishali Zadav dealing with the subject Fundamentals of Computer of class FYBBA. In the previous lecture, we have already discussed the concept of computer. What do you mean by computer? What are various characteristics, that is, features of computer, like versatility, diligence, automation, storage capacity, as well as we have discussed the block diagram of computer, means a rough sketch of computer, which include various devices like input device, output device, and CPU, that is central processing unit. And we have seen the function of each component. What is the function of input unit? What is the function of ALU? All this we have discussed in the last lecture. In today's lecture, we are going to study the programming languages. Basically, there are three types of languages: low level language, assembly language, and higher level language. So, first of all, what is programming language? The program, it is a set of instruction, set of command which is given to the computer to perform a specific operation, to perform specific command. Certain instructions are given to computer. This set of instruction, it is known as program. For example, if we want to take the addition of two numbers, then we will perform certain steps. We will type first number, then we'll type second number, then we will press plus sign, and then equal to sign. These instructions, they are required to be arranged in a particular way. Particular symbol, particular codes are to be used. This is known as program. And language. Language, it is a mode of communication. As we human being, we discuss among ourselves, we use specific language like English, Marathi, or Hindi. Similarly, to communicate with the computer, a language is to be used. The mode of communication between user and computer is called as language. So programming language, it is a set of instruction, set of command written in a specific format. Specific rules and regulations are to be followed. Then the low level language, it is divided into two types: machine language and assembly level language. And another type is higher level language. So first we will see about machine level language. It is also known as binary language. Binary language or machine language. It consists of only two states or two digits, that is 0 and 1. As the computer is an electronic device, it has only two states, either on and off. So the binary system or the binary language or machine language, it consists of only two states, on and off. On means 1 and off means 0. Now, in case of machine language, you have to write down the program. We have to write down the instructions in ones and zeros only. We are not allowed to make use of various symbol like plus sign, minus sign, or various codes, that is ADD, add. These codes are not allowed in machine language. We have to use only ones and zeros. Now, when we write the program in any language, that may be either machine language, assembly language, or higher level language, that program needs to be converted into machine language or in the binary language. We have already discussed that input unit, it converts the data and instructions into binary form. But in machine language, we already write the program in a binary form in zeros and ones. Therefore, there is no need of further conversion. And for this conversion, we require either assembler or compiler. In case of machine language, there is no need of any translator, no need of any assembler or compiler. The execution is fast, means the you will get the output immediately because it is already in the machine level format in the form of ones and zeros. Therefore, there is no need of further conversion. So its execution is very fast. We will get the output immediately. And whatever storage capabilities are there, that are fully utilized by the system. But there are certain drawbacks of this machine language, because this language is difficult to understand because it uses only ones and zeros. Now we are using our regular number system, that is a decimal number system. We use the digits from 0 to 9. Hmm? But in machine language, only 1 and 0 is used. If we want to enter number 4 in computer, in binary form, it is written as 100. Hmm? So the user, he required to know the binary code for each and every number. Even for each and every character, certain codes are allocated for character or for the symbols like addition, subtraction, equal to sign. For each of these symbol, the codes are assigned and you have to remember all these binary codes. Hmm? Then machine code related to various operations are to be remembered. Hmm. For every machine, certain memory locations or certain addresses are allocated. And for different machine, for different computer, these codes are different. So the user or the programmer, he required to remember the codes of each machine. Hmm. And these programs are not portable, means these programs are dependent on the machine. As I said, key user has to remember the codes or memory addresses for every machine. The program written for one type of computer, this program cannot be used for another type of computer because their memory locations, their memory addresses are different. So for different type of computer, you have to write down the different program. That's why we are saying that machine language is not portable language, or it is dependent on the machinery, depend on the machine. Then it is more error prone. The chances of getting error are more because you have to remember the code for each and every aspect. For example, for 4 there is 100, for 7 you have to remember 111. You have to remember all these codes, so the chances of mistake, chances of error are more in case of machine language. Then another type of low level language is assembly level language. Now, this assembly language, it is somewhat simple or easy than low level than machine level language, because in this language we are using certain symbols or certain codes are used. That like for addition we use a double d, add. Subtraction we use sub. Hmm? Then for storing we have to use str. These codes are used, these codes are known as mnemonics, and they are similar to our arithmetic or logical operations, means addition a double d, multiplication mult. These are similar to our regular operations. So my assembly language is somewhat simple and easy than machine level language. It is easy to make corrections or changes in assembly language. And you can easily identify the error, you can easily locate the errors and rectify, correct those errors. And the drawbacks of assembly level language are, it is also not portable, means you have to write down different programs for different type of computer. As in the machine language, you have to write different program for different computer system. Similarly, assembly language, it is also not portable. It depends on the type of machine, type of hardware to be used, hardware used. So you have to write down different program for different machine. So it is not portable. Then again here the hardware knowledge is required, because different programs for different computers. So you must have the hardware knowledge. And it is also time consuming. The writing coding or writing the instructions, it requires more time. And in assembly language, it requires the translator. Means whatever instructions, whatever mnemonics we are using, that are familiar to the user, that are not in the form of ones and zeros. So the translator is required to convert these mnemonics into binary form, to convert it into machine language form. So translator is required, and therefore it is time consuming, as well as the speed of execution is slow. You will get output, means for output you have to wait for some time. Hmm? Like in machine language, you immediately get output, but in case of assembly language, you have to wait for some period. Then next is higher level language. It is very simple and easy to understand, because in this language, our regular day-to-day working symbols or codes, signs are used. Like for addition, we use plus sign, multiplication, we use star mark. These regular symbols are used. So the higher level language is very easy and very simple to understand. Again, it is machine independent, means uh, you are not required to write different program for different machine. Once you have written the program, same program can be written for different types of machines. So it is machine dependent, easy to maintain, because it is our familiar words, familiar symbols, familiar signs which we are using. So it is very easy to maintain higher level language. Similarly, the size of program is also short. Hmm. And hardware knowledge is not required, as it is machine independent. You are not required to have the detailed knowledge about hardware. Hmm. Then there are certain drawbacks of higher level language, that are less flexibility and lower efficiency. As higher level language, it use the regular symbols or regular codes are used. They are need to be converted into machine level language. So they required a large amount of memory or storage capacity of the computer. Ki whatever instructions are given by the user, that are need to be converted into machine language, that are need to be converted into the binary language, and it requires the memory or storage in the computer. Hmm. Similarly, the speed of execution is slow, because first there will be conversion from regular English or decimal to binary. Again, when result is generated, binary result is converted into our regular decimal format, and then it is displayed to the user. So more time is required for the execution. So we can say it is time consuming. Now we'll see the comparison between machine language, assembly language, and higher level language. Various parameters are used for this comparison. The first one is understandability. Hmm. The machine level language, it is very difficult to write and understand, because you have to write the program in the form of zeros and ones. As compared to machine language, assembly language is somewhat simple to write and understand. Hmm. Because here we are using certain mnemonics, certain code like add, sub, div. These codes are used. So it is simple than machine language, but it is difficult than higher level language. Hmm. And high level language, it is very easy to write and understand, because we are using our regular day-to-day symbols and words. Then frequency of error, number of errors or frequency of error. Machine language programs are highly error prone, means the number of errors are more in machine language. Because it should be in zeros and ones, and remembering a binary code for each and every alphabet, each and every number, each and every symbol is very difficult. So the chances of error are more in machine language. As compared to machine language, the chances of error are less, and in high level language, there is very less possibility of error. Then we can see hardware knowledge or machine details. In case of assembly language and machine language, the programmer, he must have detailed knowledge of hardware. Because these two languages are machine dependent. They depend on the type of hardware used in that system. So for machine language and assembly language, detailed hardware knowledge is required. And in case of higher level language, as it is machine independent, the user did not require to have the detailed knowledge of hardware. Then portability, the programs are not portable. Machine language and assembly language, they are not portable, means same program cannot be used for different type of machine. if you have written the program for P5, Pentium 5, you cannot use same program for Pentium 6 or Pentium 7. You need to make certain modifications, certain changes in that program. So the programs are not portable. But high level language programs, they are portable. Means whatever program you have written for one type of machine, one type of computer, same program without any changes you can use for different type of computer. So it is portable. Then length or size of the program. In machine level language, the size is very long, the length of the program is more. Assembly language, it is means size is small as compared to machine language, and higher level language, the size is very small. Then language translator. Now basically translator means whatever instructions are given by the user that are required to be converted into machine format. For this conversion, the translators are used. There are two types of translators. One is assembler and one is compiler. Now assembler, it translate one by one line. First he convert first line, then second line, then third line. And compiler, it translate all the programs or all the instructions at the same time. So in case of assembly language, required the assembler, and in case of higher level language, we required either compiler or interpreter to convert the instructions into machine level format. But machine language or binary language, it does not require any type of translator because the instructions are already in the form of 1 and 0. Therefore, there is no need of further conversion. Then speed of execution. Machine language, this speed is very fast. Assembly language, moderate. And higher level language, very slow. Why the speed of machine level programming, machine level language is very fast? Because it is already in machine level format, in binary format, in 1 and 0 format. Therefore, there is no need of conversion. As soon as you give the input, immediately you will get output. But in case of assembly language, we are using different codes. That codes are to be converted into binary language. So it requires some time. So the speed of execution in case of assembly language is slow. And for higher level language, it is again very slow because it is very much related to the human being, our regular day-to-day language. So the speed of execution is very slow. Then memory addresses, tracking of memory addresses. The machine level language, you must the user, he must have to keep track on memory location or the memory addresses which are in used, which addresses are to be used, which are not used, which you have to use after some time. All that you have to remember. In case of assembly language also, you have to remember, you have to keep track on memory addresses, which addresses are to be used, which are not to be used. And in case of higher level language, there is no need of keeping track on memory addresses or memory locations. Now we are saying about memory, memory location, storage area. But basically, what is the memory? Memory, it is the part or the area where we can store the data and instructions. Now, data means whatever input you are giving, whatever numbers you are giving, whatever instructions you are giving, that is known as data, data and instruction. And it is in the raw fact, means there is without processed. Just you have entered the number, you have entered plus sign. That is the data and instruction. As well as it stores the intermediate result, means it store the result during the processing, means whenever the processing is carried out, that intermediate result is also stored by the memory unit or storage unit, and it also store the final output, final result is also stored by the memory. So memory is the storage area where the input, instructions, intermediate result and output, everything will be stored in the memory. There are two types of memories, primary memory and secondary memory. Today we will discuss about primary memory. Primary memory, it is also known as internal memory. Hmm. And there are two types of this primary memory. One is RAM and other is ROM. RAM stands for random access memory. Hmm. It is read write memory. Means whatever means we can enter, we can modify, we can make changes in this memory. Hmm. But this memory is volatile, or this is a temporary memory. As long as your computer is switched on, you can write or you can read the information. But as you switch off the computer, the whatever information is there in the RAM, that will get lost. Hmm. So it is temporary memory or it is volatile memory. We can read and write the information as long as computer is switched on. As you switch off the computer, the data, instruction, information, everything will get lost. Hmm. The speed of primary memory is very fast, and it is costly in nature. The another type is ROM, that is read only memory. As the name indicate, read only. You only read the information. The user is not allowed to make modification or changes in ROM. He just read that whatever information is stored on that chip, you can just read that information. So it is permanent memory, as user is not allowed to make the changes. Whatever information, whatever data is stored on the ROM, that remain as it is. So it is a permanent memory or non-volatile memory. The cost is minimum or less costly, and the speed of execution is also slow. Now, the example of ROM means whenever we switch on the computer for few minutes, for example, 1 or 2 minutes, some processing is going on. That processing is nothing but booting. That is a reading of operating system program. That operating system program is stored in the ROM. Means whenever you switch on the computer, that program is read. That program will be executed and your computer will become ready for further operations. First we'll see the types of RAM. There are two types, static RAM and dynamic RAM. Static random access memory and dynamic random access memory. The static random access memory is very fast and it is expensive in nature, while dynamic random access memory, it is less costly and the speed of execution is also slow. And ROM, there are three variations of ROM, that is PROM, EPROM, and EEPROM. PROM stands for Programmable Read Only Memory. Means whatever program is stored in the ROM, if the user or the programmer, he wants to modify or he wants to make changes in that program, the PROM chip is used. Means you can allowed to make certain changes. You means the programmer who have detailed knowledge of software and hardware, here he is able to make that changes. Hmm. Means he can add certain instructions. EPROM means erasable programmable read only memory. Whatever programs are stored on the ROM, you can erase that program, you can remove that program. But for this purpose, you have to keep that chip, memory chip, in ultraviolet rays. Depending upon the amount of data to be erased, you have to keep that chip in ultraviolet rays. The time may vary. If you want to remove small amount of information, you have to keep it for small duration of time. If you want to erase all the information or large amount of information, you have to keep that chip in ultraviolet rays for long duration. The information will get erased. But keeping that chip in ultraviolet rays, it's somewhat costly. So instead of that, EEPROM is used. That is electrically erasable, programmable, read-only memory. With the help of electric rays, electric pulse, we can erase the information from the ROM. Means instead of keeping in ultraviolet rays, with the different electric rays, we can erase the information. So in today's lecture, we have discussed about the different types of programming languages, machine level, assembly level, and high level. along with their advantages and disadvantages. Then we have discussed memory or storage unit. We have discussed only about primary memory, which includes RAM and ROM. Again, we have discussed the variations of RAM, types of RAM, static RAM and dynamic RAM, and types of ROM, PROM, EPROM, and EEPROM. Thank you.